Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, so today we'll go through one of the principle in the MEMS, that is a piezoelectric sensing and actuation. So what we will cover in this topic is what is actually piezo, the crystal behind the piezoelectricity, what are the equation related, what are the types of the piezoelectric material, and some of the applications. Okay. So let's recall back what is the difference between sensor and actuator. So actuate means you move something. When you apply some electrical component, maybe you move something, and or if it sense means you are receiving the input in terms of the voltage, frequency, or else. Okay. So in MEMS there are two directions. One is the MEMS sensor, another one is MEMS actuator. So when we're talking about sensor, all your input is coming from the motion, let's say from the temperature or from the sound or audio. Your output must be in the form of electrical signal. So for example, like a thermometer, a motion sensor, and so on. But when we're talking about micro actuators, the output is in terms of the mechanical change or physical change. Either it will be elongate or it will be bending, if it is a cantilever, right, or it will pop up some droplet. So this is what we call actuator. Example is the fluidic micro actuator, piezo actuator, or micro mirrors. Okay. So to build the micro actuator and micro sensor, so you need some power. So for MEMS sensor, we need a very small power and to allow the sensor to work. But for actuator, you need much more high power in order for the device to have the physical change. Okay, because you need some mechanical part there. So there are two ways here. Okay, so in order to have either sensor or actuator, so there are four important principles here. The first one is piezoelectric, electrostatic, the third one is electromagnetic, and the fourth one is thermal. So all these principles will be able to become either sensors or either actuators, depend on the application. So what we are going to focus on is only the piezoelectric principles. So some of the example is piezo speakers, the autofocus, the inkjet haze, and so on. Okay. So what is actually piezo? Piezo is coming from the Greek word. So the meaning of the piezo is to squeeze or to press. Means you have a special material. So this is what we call a smart material. The material must be piezoelectric. So when you squeeze or you press the material, it will produce what we call electric charge. So this does not happen to any material, only special material that we call piezo material. When we squeeze or we apply the stress on the material, it will produce an electric charge. So the effect is also reversible. So this is what we call direct effect, direct piezo effect, but the effect also can be reversible, where when you apply the charge, the voltage at the piezo, let's say you apply the voltage, so the piezo will deform, will have a physical change. Either it is bent or either it is deformed and have some mechanical change there. Okay, so let's say from this figure 3, okay, this is the molecular structure inside the piezo material. Let's say this is a quartz material. Okay, so when you apply the stress, so when you start to squeeze the material or you start to elongate the material, it will having a charge accumulate on top and at the bottom here. So this charge will lead to a voltage, right? So means that this is a converse a direct effect. Sorry, this is a direct effect. When you squeeze or you allocate the piezo material, you have a charge accumulate at the piezo material, and you will have either voltage or any electrical signal. For part C, when you apply the compressive stress, So there are two terms here. One is a tensile, one is compressive. So tensile means you elongate the material. Compressive means you squeeze the material. So either it is squeeze or you elongate it, you are going to have what we call accumulation of charge on top and the bottom of the material. So this is what we call direct effect of the piezo material. Okay, so let's see this figure. So again, this is a piezo material. So once you apply the stress, this is a compressive stress. So you have some reading at the voltage if you connect top and bottom of your material with some connection to the multimeter or the voltage source. So the piezo element will generate a voltage when it is deformed. So why we call this one deformed? When you apply the stress. So it can be either the tensile or the compressive stress. So this is what we call direct effect. The second effect, that is when you apply the voltage. So means here you are going to apply the voltage, either positive and negative. Your piezo will be deformed, or will be bent, or will change the physical structure. Okay, this is what we call reverse effect. Okay, who found the history of this piezoelectricity is from this man. His name is Perry and Jackie Curie. He's the one who invented this piezo material, and he started use the quartz-based sonar and find out about this miracle material. Okay, again, I will emphasize here. So there are two effects. The first one is direct effect. The second one is converse effect. So when talking about direct effect, this is more on to have for you to have the application of the sensor. But if you want to make the converse effect, it is more on the actuator, because you're going to move or you have to physically change on the piezo material. So direct effect, when you apply the stress. So this is the stress that either compressive stress or tensile stress, you are going to receive the output is the voltage. The accumulation of charge will be at the top and at the bottom. What will happen at the other one? Converse piezoelectric effect, when you apply, so the input here is the voltage. So what will be the output? The output is the material will be deformed. Just now the direct piezoelectric effect, the input is actually the stress here. This is the input. When you compress or you squeeze or you apply the tensile stress, you will have some reading at the voltage output. Okay, so this will be the first part of the piezoelectric. We will continue on the next video. Okay, Assalamualaikum.